My dear students, you will successfully complete your plus 1 class. Now we move on plus 2. In plus 1, all of you got your percentage as 85, 87 and 82 in physics, chemistry and maths respectively. In my advice, you must improve your marks as 95, 97, 92 in plus 2. Here, this information of marks we can rewrite as 85, 87, 82, 95, 97, 92. We all familiar rows and columns, right? The horizontal lines of numbers are said to constitute row, which means this is our first row and this is our second row. The vertical lines of numbers are said to constitute columns, which means this is our first column, this is second one, and this is our third column. I enclose this arrangement using a closed bracket. So this is a rectangular array of numbers arranged into rows and columns enclosed by the symbol closed bracket. In mathematics, this type of arrangement we known as matrix. So my dear students, today I like to introduce a new chapter, matrices. So this is our first chapter. A matrix is a rectangular array of numbers or functions arranged into rows and columns enclosed by the symbol closed bracket or open bracket. This is the definition of matrix. The numbers here, 85 as the number in this matrix, 87 again a number in this matrix, 82 is again a number in this matrix. The numbers or functions in a matrix are called elements. The numbers or functions in a matrix are called the elements of a matrix or entries in the matrix. The matrices are usually be denoted by capital letters of English alphabet, namely capital A or B, etc. Here one example is matrix A equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 are the elements of the matrix, and A is the name of the matrix. Next we discuss order of the matrix. Order of the matrix is number of rows into number of columns. For an example, matrix B equal to 5, 4, 5, 6, 10, 8, 9. Order of matrix B equal to here number of rows is, this is our first row and this one is our second row. So number of rows is 2. Then we put a cross symbol. Number of column is 1, 2 and 3. So we write 3. But we read it as 2 by 3, not 2 cross 3 or 2 into 3. We read it as 2 by 3. Order of matrix is number of rows by number of columns. Next we move on. General form of a matrix. General form of a matrix or M by N matrix. We consider a matrix A with M rows and N columns. We expressed matrix A equal to, okay, here M rows, which means 1, 2, 3, etc. up to N rows, and M column means 1, 2, etc. up to N column. First we put a enclosed symbol, closed bracket. Now we use small letter A as or instead of every element. But the suffix decide the position of the element in the matrix, which means here we consider the first element A. Here A, this element in the first row and first column. So we write it as A11. In suffix we write the position of row and column. Next we consider the second one. We can simply write A first row and the second column. So A12, and this one is A13. Continuing, we can write this element as A first row and the nth column. So A1n. Similarly, we can write this as A21, A22, A23, etc. up to A2n. Here we write A31, A32, A33, etc. A3n. This element we can write A here, mth row and the first column. So we can write A M1, second element as M2, third element A M3, and this last element in mth row and nth column. So we can write A M n. So this is our general form of a matrix with order M by n. Here M is the number of rows and n is the number of columns. Generally, we can say that Aij, this is an element in this matrix, which means is the element, Aij is the element in ith row and jth column. Aij is the element in ith row and jth column. We use the following notation, namely A equal to matrix Aij, m by n in suffix, which means A is a matrix of order m by n. A is a matrix which order is m by n. A matrix of order m by n has mn elements. Matrix of order m by n has mn, which means m into n elements. For an example, A is a matrix, 1, 2, 3, 4, 5, 6. Here, order of this matrix is, first we write number of rows. Number of rows is 1, 2, 3. So, order of the matrix equal to number of rows is 3 by number of column is 1, 2. So, we can write 2. Order of the matrix is 3 by 2 and number of elements equal to here 1, 2, 3, 4, 5, 6. So, number of elements is 6. We can find that 3 into 2 is 6. So, we can say that a matrix of order m by n has mn elements. Now, we move on problem section. Okay. In the matrix A, the first question, matrix A equal to 2, minus 5, 1, 0, 3, 7, 8, root 3, minus 1, 0, 3, 7. First part, find the order of the matrix. Order of the matrix. We know that order of the matrix is number of rows by number of columns. Number of rows here 1, 2, 3. So 3 by number of column 1, 2, 3, 4. So our order of the matrix is 3 by 4. Second part, number of elements. Number of elements, we already discussed. M by n ordered matrix has mn elements. So here we can find number of elements as 12. 3 into 4 is 12 elements in this matrix A. Third part, write the elements A21. A21. Here A21 means a element which position is 2th row and the first column. Here A21 is, here this is our first row, second row, third row, and this is first column, second column, third column, and fourth column. Here A21 means second row and the first column, which means that element is 3. Next one, A33. A33 means the element in the position third row and the third column. We can easily write it as 3 as the element. Next, A24. A24 means this element lies in the second row and the fourth column. That element is root 3. So this is our answer. We move on. Next question. Consider a 2 by 2 matrix. Consider a 2 by 2 matrix. Capital A equal to matrix Aij. It's a general notation. Where Aij equal to modulus 2i minus 3j. Write matrix A. This is our question. Consider a 2 by 2 matrix A equal to matrix Aij, where Aij equal to modulus 2i minus 3j. Write matrix A. First, we want to write matrix A in general form. Here, given that matrix A is 2 by 2 matrix, which means the element in generally we can write A1, 1, A1, 2, A2, 1, and A2, 2. Now, Aij is given, Aij equal to modulus 2i minus 3j. Aij is the general element. So, we can easily write A11 as modulus 2 into, we put 1 instead of I, and we put again 1 instead of j. We get 2 minus 3 equal to modulus minus 1. Modulus minus 1 equal to 1. Next one, A12. Modulus 2 into 1 minus 3 into, here 2 is instead of j, so we can write 3 into 2, which is equal to modulus 2 minus 6, which is equal to modulus minus 4 equal to 4. Next element, A21. Modulus 2 into, here 2 equal to I, so we can write 2 minus 3 into 1, modulus 4 minus 3, which is equal to modulus 1, which is equal to 1. And the last element, A22. Modulus 2 into 2 minus 3 into 2, we get 4 minus 6, which is equal to modulus minus 2, which is equal to 2. So, now we get all the elements of matrix A. So, we can write matrix A equal to 1, 4, 1, 2. This is our answer. Next, we move on. Types of matrices. Types of matrices. In this section, we discuss certain type of matrices based on their order and elements. First one, column matrix. A matrix having only one column is called a column matrix. Here we mention only one column. For an example, matrix A equal to 1, 2, 3. Here order of the matrix is number of rows is 3, number of column is 1. So in this matrix having only one column, so this matrix is known as column matrix. Second one, row matrix. A matrix having only one row is called a row matrix. Here only one row. For an example, matrix B equal to 1, 2, 3. Here order of the matrix is 1 row and the 3 columns, so 1 by 3. Here number of rows is 1, so this is an example for row matrix. One by matrix is a both row matrix and column matrix. Please write it down as a note. 1 by 1 matrix is both a row matrix and a column matrix. Next, third one, square matrix. A matrix in which the number of rows equal to number of columns is called a square matrix. That's the specialty of square matrix. Here an example, matrix C equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Order of this matrix is number of rows is 3 and number of columns is again 3. Here number of rows equal to number of columns. So this matrix is known as square matrix. Next we discuss diagonal element. Diagonal elements. Okay, we already studied general matrix A, A11, A12, etc., A1n, A21, A22, etc., A2n, A31, A32, A33, here A13, A23, etc., A3n. Continuing, I take here a square matrix. So number of rows and number of columns, I consider it as n. So this is n1, n2, etc. Sorry, n 3, etc. A, n, n. This is our last element because I consider a square matrix which order m by n. Diagonal element means A11, A22, A33, etc. ANN. These elements are called main diagonal elements. A11, A22, A33, AN, etc. ANN. These are known as diagonal elements in a square matrix. Now, the fourth matrix is diagonal matrix. Diagonal matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. For example, we can write matrix A equal to 1, 0, 0, 0, 8, 0, 0, 0, 3. Order of this matrix is 3 by 3. This is a square matrix. Here, diagonal elements are 1, 8, 3. Non-diagonal elements are 0. This type of matrices are known as diagonal matrix. Next, scalar matrix. Fifth one, scalar matrix. A square matrix is said to be a scalar matrix if the diagonal elements are equal and the non-diagonal elements are 0. Diagonal elements are equal and non-diagonal elements are 0. For an example, matrix B equal to 5, 0, 0, 5. Order of this matrix is 2 by 2 and this is square matrix, and here diagonal elements are 5, 5. So diagonal elements are equal, non-diagonal elements are 0. Next one, identity matrix or unit matrix. Sixth one, identity matrix or unit matrix. A square matrix in which the element in the main diagonal are all 1 and other elements are 0 is called an identity matrix or unit matrix. For example, matrix C equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Order of this matrix is 3 by 3. Here, diagonal elements are 1 and non-diagonal elements are 0. This type of square matrix are known as identity matrix. Seventh one, zero matrix or null matrix. A matrix in which all the elements are zeros is called a zero matrix or null matrix. For example, matrix A equal to 0, 0, 0, 0. Order of this matrix is 2 by 2. All these elements in this matrix is zeros. Next, we move on. Equality of matrices. Equality of matrices. Two matrices are said to be equal if they are in same order and the corresponding elements are equal. Two matrices which satisfying these two conditions, then we can say is that two matrices are equal. Okay, we move on a question. Find the value of x, y and z from the following equations: 4, 3, x, 5 equal to y, z, 1, 5. Here, given that these two matrices are equal, so in equality of matrices, we know that they are in the same order because first one is 2 by 2, second order of this matrix is 2 by 2. And the second condition, the corresponding elements are equal. So we can easily write as 4 and y are equal, 3 and z are equal, x and 1 are equal. So our answer is x is equal to 1, y is equal to 4 and z is equal to 3. Okay, thank you.